Okay, let's kind of roll into one, defining the equation for an arithmetic mean with a worked out example. So once again, we're dealing with case three, which is the case where you're working with a data set, but you don't have the datums. But you do have a frequency table or you have a histogram. So just from this, you can calculate the median of this random variable that these two, this table and this histogram is representing. So before I proceed, I want to also again point out that if you're looking at the PDF of this, I've got these mastery question links. And so if you click on them and you want to practice this type of problem some more, if you click on it, it'll open up a My Open Math question in your web browser. And, it gives you the formula in this one. And these are the individual variables for this formula. And then this is the answer that this formula or equation gives you. And you can test your knowledge by clicking submit. It'll tell you whether you are right or wrong. And if you want to keep working on it until you gain mastery of it, you can click try similar question and it'll regenerate a new problem for you. Okay. There's that one. And then this other one is, I want to say a little more progressively, a little more challenging in that this one, it gives you the same type of problem. Let's see here. No, it's just the same type of problem. Oh, I know. So this one is skewed. Okay. So this is a data set which is a skewed distribution. So this one is meant to kind of show you, where the median would be if the data set was a skewed distribution here, contrasting to the other one where it was more normally distributed, that it's symmetrical. Okay. Um, so yeah, this example is meant to be symmetrical, and this one was meant to be skewed. Again, asking for the same variables in the same equation, and you can test and see whether your answer is correct. All right. So let's kind of look at now how to calculate the arithmetic mean. So I did just point out, I just said arithmetic mean. I meant arithmetic median. All right, so here's the equation for the arithmetic median, and it looks pretty daunting at first because there's all of these abbreviations and variables in it, but we'll break it down. If you want a definition for each of these, that's what I have off to the side. LCB subscript med, this is the lower class boundary of the class or interval that includes the median. W is the width of each class. N is the sample size. CF minus the median is the cumulative frequency of the classes or intervals preceding the median class. And FMED is the frequency of the median class. All right, so we'll kind of work through an example problem, which is this one, and we'll define each of those variables. And I think you'll see that it's not quite as daunting as it may look. All right, so we want to calculate the median of this data set represented by this frequency table and histogram. So what we need is we need each of the equation variables. So let's start from the easiest one. So the easiest one we can get is the width. How do we get the width? Well, the width is either going to be the difference between the lower bound and the upper bound in a class. So here, the difference between 330 and 338 is going to be a difference of 8. Or with the histogram, we could maybe look at a difference of midpoints. So here's a midpoint of 310. Here's the next midpoint, which is 318. And the difference between these two is 8. Okay, same number. So our width is 8. So we have this variable now defined in this equation. The next easiest one is going to be n. So n is sample size. So how do we get the sample size? Let me use a different color here. How do we get sample size? Well, the sample size is just the sum of all the frequencies. So to get the sum of all the frequencies, we can just use our calculator and we can add all of those numbers up. We can do it on the table, or we can do it by adding up all these frequencies in the histogram. Either one will work. And so when we add up all of those frequencies, we get 150. So there's 150 datums total in this data set that this table and this histogram are representing. So our value of n is going to go right here in our equation, and we'll end up dividing that by 2. Okay, so those are probably the two easiest to identify, and we can get those right off the bat. But what we're missing still is we're missing this lower class boundary of the median, frequency of the median class, and the cumulative frequency not including the median class. So we still need those three. But notice what we need to do next is we need to identify what is the median class, okay? Because these variables are kind of based off of identifying the median class. And that's what I've got here for part 3, is identify the median class. How? The median is a value whereby half of the datums are smaller and half are larger. So since we know there's 150 datums in this data set, remember we just figured that out, the median value is going to be the 75th datum. So half of 150, right? 150 divided by 2 is 75. So the 75th datum is going to be the median datum. So now, in which class will the 75th datum fall into? So what we need to do, so in which class will the 75th datum fall into? What we want to do is we want to start adding the frequencies together, all right? And figuring out the sum of the frequencies that are lower than 75 and larger than 75, okay? So it turns out, you can see that if I sum up the frequencies of the first 5 classes, 2 plus 5 plus 14 plus 22, so if I add these frequencies together, that gives me a value of 48. So that gives me 48 datums. So there are 48 datums in these first 5 classes. Now, if I add up the first 6 classes, so 2 plus 5 plus 5 plus 14 plus 22 plus 31, 31 is the 6th class. So if I add all of these together, then what I get is I get 79 datums. So if the first 5 have 48 datums and the first 6 is 79 datums, then where is the 75th going to land? Well, the 75th datum is greater than 48 and less than 79. So the 75th datum is going to be inside this 6th class. Okay, so this 6th class is what we call the median class. So the median is going to be in the 6th class, and this is called the median class. So this variable here, the lower class boundary of the median class, what's that going to be? Well, let's come up to our table. Here is the sixth class, and here's the lower bound for the sixth class. So that's going to be 274. Now, what's the frequency of the median class? Well, the frequency of the median class is 31. So now we have that one. And what was the cumulative frequency preceding the median class? This minus med, this means not including the median class. So what was the cumulative frequency not including the median class? Use a different color here. So if we come down, we already have that. That was 48. 48 was the cumulative frequency not including the median class. So this number is going to be 48. Now we have every single variable we can substitute with a number. And we got most of that just by doing some simple math and looking at our picture. So now what we need to do is take each of these variables and substitute those values in. So the lower class boundary of the median class is 274, so we can put in 274. The width is 8. Sample size was 150. The cumulative frequency, not including the median class, is 48, so it's going to be minus 48. The frequency of the median class is 31. And if we put all this into the calculator, we'll get 280.97. So let me show you what that looks like if we put that in the calculator. What you need to be careful of when you put this into the calculator is you really have to pay attention to all of these parentheses, especially these ones here inside where you're doing this fraction. That's probably the most important one. You have to get those parentheses correct. And that takes a little bit of practice when you're doing it in the calculator. It's one thing to see it on the screen. It's one thing to actually write it on a piece of paper, but it's another thing to keep track of those parentheses when you're using the calculator. So keep this image here in mind. I'm going to flip over to the calculator. Let me use the Texas Instruments first. And yeah, let me turn this on. And let me hit quit to get back over to this screen. All right, so if I wanted to put those values in with parentheses, this is how I would do it. I am going to put maybe a little extra parentheses just to kind of show you how it works. So first we have the lower class boundary of the median class. So I'm just going to go ahead and put that in parentheses. So we've got 274, left and right parentheses around that. And then we got plus the width. Now this is where it gets a little tricky with a bunch of parentheses. I'm going to exclude a few to keep it simple, okay? So the first thing we need is we need this left parentheses. And let's see, how should I? Okay, yeah, so let me do the outer parentheses first. So there's, well, it won't let me insert. Okay. Okay, so we have the left parentheses first. Now we need to hit parentheses again and put 150 divided by 2 and close that off. And then we'll subtract 48. Now there's an extra parentheses I should have put in here because we want to make sure that all of this occurs in the numerator first before we divide by the denominator. So let's put a parentheses here, and we'll put another one. Let's see here. So this is all going to be the numerator. Let me come back over here. And let me insert another parentheses. Okay, so to insert, you just hit second and the delete key, and that'll put you in an insertion mode. Okay, And we want to take this numerator and we want to divide that by 31. And then we'll put close parentheses. And actually, that should be it. So let's kind of look at these parentheses. So when we look from here over, we have 3 left parentheses, and we've got 3 right parentheses. We should have the same number, okay? This left and this right parentheses is kind of protecting this 150 divided by 2. Then working outwards, this left parentheses goes with this right parentheses. And this is kind of making sure that everything in the numerator gets done first before we divide it by 31. And this outer left parentheses here matches with this outer right parentheses here. And what that does is that encloses this entire term. So all of this will get resolved before it gets multiplied by 8. Okay. And now we should be able to hit enter and we get 280.97, okay, which is the answer that I calculated before. You can do this another way. Instead of doing it all at once, we could maybe do it from the inside and work our way out. So what do I mean by that? We could have done 150 divided by 2, and then subtracted 48, and then divided by 31. So notice I'm doing everything that was within that fraction that we had in the equation. And then I'm going to multiply by 8. And then I'm going to add 274. And that gives me 280.97. Okay, so that's another way to do it. If you don't feel, as safe and secure, to do it this way, then you can do it piecemeal like I just did it. This is kind of powerful to be able to do it all at once, but you're certainly not pushed to have to do it that way. Whichever way you feel comfortable. All right, let's take a look at this on the NUMWORKS calculator. I think it might be a little bit easier to visualize with the NUMWORKS calculator. So what you want to do is you want to go into the calculation app. So you want to make sure that you kind of scroll around to the calculation app and click OK. And let's see here. So let's start typing this in. So we've got 274 plus 8. All right, now we're going to have a series of parentheses. So let's see here. Let's have this parentheses. We'll have another one for the numerator. And we're going to have another one for 150 divided by 2, like that. Oops. Back. And let me go out. So I can put a right parentheses there. Okay, so there's 150 divided by 2. And then we're going to subtract 48. And now we need to close this numerator off with a parentheses. And now we want to take this numerator and divide it by 31. So you can kind of see here that, this NUMWORKS calculator appears to maybe be building this equation a little bit more like, your lecture notes, how it looks on your lecture notes. We might be able to do that with the Texas Instruments. Let me flip over and try that here in a second. So we can hit execute and we get 280.97. So the same answer that we got before. Let me flip back over to the Texas Instruments. Let me see if I can, because I think we might be able to go into the mode and, well, it's in Math Print. I think Math Print was the thing I was thinking of that would kind of make it look like the NUMWORKS calculator just did. Yeah. Okay. So yeah, I think I don't think we can really make that any better. So yeah, this is kind of one of the things that I think the NumWorks calculator does a little bit better than the Texas Instruments, is that if you build kind of an equation with the Texas Instruments, you have to do it on a line like this, as far as I know. And with the NumWorks calculator, you can build the equation and it kind of builds it more like how you would see it on a page or how you write it on a piece of paper, which I think helps make it a little bit more approachable. All right. So, again, the math wasn't, and the calculator intensity wasn't nearly as much as the arithmetic mean. So what we calculated is one of the measures of center. We calculated the arithmetic median using case three. Case three is we do not have access to the data set of datums themselves. We only have access to the frequency table or the histogram. But based off of that, we can use its formula and calculate the arithmetic median. Let me know if you have any questions.